So the first thing I want to talk about when it comes to building a machine as part of a hobbyist sort of thing, building your first machine, there's a few things you need to consider. And the first one of them is the air gap. For the machine to work, we're going to have, in some way, shape or form, we're going to have a magnetic field like this, and we're going to have a coil that's going to be rotating in there. And when we pass a current through that coil, that's going to be going like this. We're going to have our right-hand rule apply. The magnetic field that exists through here from our permanent magnet, or it might not be a permanent magnet, it might be a moving magnetic field, but for this particular case, a permanent magnet. This magnetic field is going to interact with the magnetic field that's created around our conductor, and that's going to provide our force. To make that force greater, there are several things we can do. We can increase the number of coils here, the number of turns. So we have our wire coming in, multiple turns. Multiple ones of these means much more stronger field to interact with the existing one. We can increase the size of the magnetic fields. But one thing to make the machine efficient that a lot of people fail to address is the simple distance between these 2 points here, this distance here, the air gap. And we can see that with some early iterations of some of the ones that have been built and I've got lying around here from some students have built. And most of these are early iterations. The students have abandoned them because they realised they were wrong and they weren't going to work, and some of them did work and they didn't work well and they were going to make better. If we look at a commercial machine, which I've got one here, here's our stator on the outside. This is actually an induction machine, but the principles still apply. And we've got our rotor here, and we can see that when we put this together, we can see here that the distance between our field and, in this case, our squirrel cage is sub-millimetre. We look at the sorts of machines that some students build early on in their process, and here's an example here. And this machine works perfectly well. We can apply voltage here. It comes up through the commutator here, energizes the coil, it interacts with these permanent magnets. But in this particular case here, it's been built with 3 bolts. We can see that their air gap is around 5 millimetres. And that'll work, but it's not going to work as well as it could. Now, this is a vertical axis one. It's not particularly stable, and this can pose a bit of a problem because if we were to work on a sub-millimetre air gap like that commercial machine over here, then with this moving around, we can easily see how we have some travel over here. An example of what some students do that's not the best, and this is again a very early iteration, students abandoned this one very early in the piece, is this one here. And we can see we've got our field, our coil here, some permanent magnets here, and this particular case, we're looking at in excess of 1 centimetre there. That's certainly suboptimal. It's not difficult to reduce that gap down to several millimetres, like we saw with this one here. And I would strongly advise that students work to do that. It'll make your machine more efficient, and if you want your machine to do any real work, you're going to need that. Here's an example of a machine that was made. This one they used a 3D printer to build up the framework here. We've got, again, 3 coils which can be individually energized. These are configured in star, as you can probably guess from the 4 wires coming out. And the air gap between the permanent magnet and the rotor and the energized coils on the outside is in the order of 1.5 millimeters. This machine worked wonderfully well, and one of the reasons it worked wonderfully well is because of that much reduced air gap. An example of, if you're using decent bearings to mount your rotor, then you're not going to have any travel. This one here has got a bearing at each end, so there's no travel in here. As I pointed out earlier, this one has only got one bearing, and as a result we see a lot of this. This one over here has no bearings. You can simply see it's a bit of a dowel put through some bolts, and we've got a lot of travel there. So this was just an initial proof of concept that some students did, and the reason I'm showing it to you is to show you the massive air gap. I mean, I can actually get my finger inside there. Okay, so that's the first consideration that you need to think about. The first area for getting a machine that could be optimized and made better is the air gap. Thank you for watching.